Okay, this was quiz 3 from a while back. This was during unit 2. So here we have, again, quiz 3 is parallel lines cut by a transversal. So we're all stuff about alternate interior angles, same side interior angles, and all that other stuff. Okay, so question 1 says let M be parallel to N. So M and N are going to be parallel lines. And the measured angle C is 120 degrees. Okay. Find the measure of the following angles and give a justification for your answer. Your justification should be identifying the relationship each angle has to angle C. So A is the first one. So what's the relationship between angle A and angle C? Okay, well, those are a linear pair. Remember, if we have, if the angles have the same vertex, right? In this case, they have the same vertex. Our options are linear pairs or vertical angles. Okay, it's not going to be anything other than those two, linear pairs or vertical angles. If they're at different intersection points and we have parallel lines, right? So if the vertices are on a transversal that goes through two different parallel lines, so their options are going to be, well, they don't necessarily have to even be parallel lines. So if we just have them on the same transversal, the same line going through two other lines. Then we have alternate interior angles, same side interior angles, same side exterior angles, alternate exterior angles, and corresponding angles. If the lines are parallel, then we either know those angles are going to be supplementary or congruent, depending on which one it is. So A, right, these are a linear pair, so they're supplementary. So their measures add up to 180. So if we do 180 minus 120, we're going to get 60. So the measure of angle A is going to be 60 degrees. Okay, and the justification is it's a linear pair with angle C. A is a linear pair with angle C. Okay, second question is for B. Okay, so these are vertical angles. We know vertical angles by the vertical angle theorem are congruent, so vertical angles are always congruent. So since we have vertical angles, they're congruent. So the measure of angle B is going to be 120 because it's vertical with angle C. They form vertical angles. Okay, we could probably use a little bit better of a justification, like a better explanation here. Like instead of just saying vertical with angle C, we could say angle B forms a vertical pair with angle C, or angle B and angle C are vertical angles or something like that. But vertical with angle C, we know what we're talking about. We know what we all mean. That's fine. Okay. Angle E, so E and C. Angle E and C, first question we have to ask, do they have the same vertex? So are they at the same vertex? No. So we know it's not going to be a linear pair. It's not going to be a vertical angle. It's going to be one of the other 5. Right? There's 7 total vertical angles, linear pairs. Then we have our other 5, corresponding, alternate interior, alternate exterior, same side interior, same side exterior. Right? So if they're at different vertices, we know it's not going to be vertical or linear. So we have to ask ourselves, are they here's our transversal. Okay. Are they on the same side of the transversal, or are they on different sides? The answer is they're both on this side. Yes, so they're on the same side, right? This angle, let me clean everything off. All right, and let's look at so here's our transversal, T. And follow the line as closely as I can. Here's angle C, and here's angle E. They are both on this side of the transversal, as opposed to this side. They're on this side, same side. Okay, and the second question we have to ask, are they between the parallel lines or on opposite sides? I mean, between the parallel lines or on the outside of the parallel lines? Right, so they're in between the parallel. Here's our parallel lines, M and N. Okay, they're in between the parallel lines. So we have same side of the transversal, in between the parallel lines, so they are same side interior. Same side of the transversal, they're both angles C and E are on the same side of the transversal, and they're both between the lines M and N. So they're between the parallel lines, so they're interior, they're inside the parallel lines. So we're going to have same side interior. We know same side interior angles are supplementary. So if this one was 120, this one's going to be 60, 180 minus 120, which is 60. So 60, and the justification is same side interior with angle C. Same side interior with angle C. Next one is F. So the question here is, are they on the same side of the transversal? Here's our transversal. On the same side, or are they on opposite sides? In this case, they are on opposite sides. One's on the east side, one's on the west side, right? Opposite sides of the transversal. So we know it's going to be alternate. There are alternate sides. Alternate. The question is alternate interior or alternate exterior. Well, are they both inside the parallel lines? They're both outside the parallel lines. Right, well, they're both in between. They're in between. They're on the interior of the parallel lines. So we have alternate interior. So alternate interior with angle C. So if angle C is 120, we know alternate interior angles are congruent. So if angle C is 120, if the measure of angle C is 120, then the measure of angle F is also going to be 120 degrees. Okay, G. Okay, this is going to end up being our fifth option. So if we notice, and if we go through our process, are they on the same side of the transversal or different sides? They are on the same side. They're both on this side of the transversal. So same side of the transversal. Are they both, okay, we either have same side interior or same side exterior. So are they both inside the two parallel lines? No. Angle C is on the inside, okay, but angle G is on the outside. Okay, so they're not both same side interior or same side exterior, which means we should probably look at our fifth option, which is corresponding angles. I'm starting to get sick, but I'm not going to miss school, guys. Don't get excited about that. So we have to go to our fifth option. Right, they're on the same side, but they're not same side interior or same side exterior. So we're going to have to look at our fifth option, which is corresponding. Okay, which is the same location, right? So if you picked up this intersection point and put it on top of this one, what's going to be in the same place as C? It's going to be G, right? If we pick this up, put it right on top of the next one, C is going to be in the same spot as G. They're in corresponding locations. So angle C and angle G are corresponding angles. What do we know about corresponding angles? We know they are congruent. So if the measure of angle C is 120, the measure of angle G is also going to be 120. And the reason is that angle G is corresponding to the corresponding angle with angle C. Angle G is corresponding with angle C. Number 2. Okay, number 2. First thing we have to figure out is what kind of angle relationship we have here. Okay, it's telling us that M and N are parallel. So we're probably going to use one of our theorems. All right, first thing we notice about the two angles they give us, these two. All right, first thing we have to ask ourselves is, are they at the same vertices or different vertices? They're at different vertices. So that rules out linear pairs or vertical angles. These are not linear pairs. They're not vertical angles because they're at different vertices. So next thing, it's going to be one of our 5 other ones. Are they on the same side of the transversal or different side? So here's our transversal. They're on the same side of the transversal or different sides? Well, both angles are on this side. So they're on this side of the transversal. So they're on the same side of the transversal. Are they both inside the parallel lines or outside? Okay, and the answer again is no. They're not both inside the lines, right? This one's inside. This one is outside. So they're also not going to be both outside. So it's not same side interior. It's not same side exterior. We need to look at our fifth option. Okay, the fifth option for them both being on the same sides of the transversal is going to be corresponding angles. And are they corresponding angles? Yes, they're in the corresponding location. If we pick up the top one, put it over the second one, right? Where's 2x minus 5 going to be? It's going to be right on top of 21x plus 5. So what do we know about corresponding angles? We know corresponding angles are congruent. So their angle measures are equal. Since their angle measures are equal, we know 23x minus 5 is going to equal 21x plus 5. Okay. Subtract 21x from both sides. We get 2x minus 5 equals 5. Add 5 to both sides. Okay, we're going to end up with 2x equals 10. Divide by 2. X is going to be 5. And the question is just asking us to find the value of x. If we want to check and see if our answer was right, we can substitute it back in. 21 times 5 plus 5. So 21 times 5 is 105, right? 5 times 20 is 100. 1 times 5 is 5. 100 plus 5 is 105. So it's going to give us a total of 110. 23 times 5. Okay. This one we can do 25 times 5 is 125. Minus 10 is going to be 115, right? Because 25 times 5 minus 2 times 5, right? Combined to give us 23 times 5. So we know it's going to be 115 minus 5, which gives us 110, right? Checked our answer. We know we are correct. Okay. Number 3. Okay, are they at the same intersection point? No. So not vertical, not linear pairs. Right? They're at different intersections. Are they on the same side of the transversal or opposite sides? Well, they're on the same side of the transversal. Here's our transversal. It's easier when it's going this way and I can see what I'm tracing. Okay. Are they both on the inside of the parallel line? So here's our parallel lines, M and N. Are they on the inside? Yes, they are on the interior. They're between the parallel lines, M and N. We're between the parallel lines. So they're same side interior. What do we know about same side interior angles? We know same side interior angles are supplementary, meaning their angle measures add up to 180 degrees. So 8x plus 6 plus 14x minus 2 is going to equal 180 degrees. Combine like terms, 8x and 14x is 22x. 6 and negative 2 is a plus 4. Minus 4 from both sides, 22x is going to be 176. Okay, divide by 22. All right, so 22 goes into 88 4 times. 88 goes into 176 twice, so it's going to be 8. Right? I think. Yeah. Right? 22, 44, 66, 88. 88 times 2 is 176. Okay, we want to check our answers. 8 times 8 plus 6. 64 plus 6, that's 70. 14 times 8. So 104. Wait. 14 times 8, so that's going to be, 104, right? Minus 2 is 100, no. 112. Okay, minus 2 is going to be 110. So these are going to add up to 180, right? 70 plus 110 is 180. So we know we're right. At least we know we did the algebra right. We don't know for sure we're 100% right, but we know we did the algebra right. Where's my paper towel? Okay. Number 4, same thing, except this time we're just going to combine it together into one problem. We have 2 variables. We're going to have to come up with a second equation. Right, two variables. You want to solve two variables, you're going to need two equations. You have three variables, you're going to need three equations. All right. I would look at just the ones with the x variables first. So let's look at these two angles. Are these two angles on the same side of the transversal or alternate sides of the transversal? Well, they're on different sides of the transversal. Here's our transversal. They're on alternate sides. One's on that side, one's on this side. Are they both in between the parallel lines, M and N? Yes, they're both in between. They're in this space right here. Right? They're in the middle. So they are alternate sides of the transversal. Inside of the parallel lines, they're alternate interior angles. What do we know about alternate interior angles? We know alternate interior angles are congruent, so their angle measures are equal. So 2x plus 13 equals 3x minus 24. Subtract 2x from both sides. 13 equals x minus 24. Add 24 to both sides. 37 is going to be x. Okay, so that's one answer right there. Now we need to find y. Okay, we have two options. We either can do a linear pair here, right? So these are having the same vertex. So they form a linear pair. So we can have 2x plus 13 plus 3y plus 24. It's going to be 180 because we know linear pairs are supplementary. So their angle measures add up to 180. Or we would have, these are same side of the transversal. Okay. Same side of the transversal. They're both on the inside, so they're same side interior angles. And we know same side interior angles are supplementary. So here we would have 3x minus 24 plus 3y plus 24 is 180 because we know same side interior angles are supplementary. Either equation will be fine. We substitute in the 37. Right, so 2 times 37 plus 13 plus 3y plus 24 is 180. 2 times 37 is 74. So we have 74 plus 13 plus 3y plus 24 is 180. Okay, 74, 13, and 24. Okay. So this is going to give us 78, 88, 98 plus 3 is 101 plus 10 is 111. So it's going to give us 111. Okay, and then plus 3y is 180. Okay. Subtract 111 from both sides. 3y is going to be equal to 69. 79, 69. Okay, divide by 3, and we're going to get y is equal to 23. 23. We could have plugged 37 in first before we wrote our equation. So we could have said 2 times 37 is 74 plus 13 is 87, right? 3, this should also be 87 because alternate interior angles are congruent. 3 times 37, okay? So that's going to be 120 minus 9, 131. What am I doing? No, 111, right? 111 minus 24 is going to give us 87. 87 and 87. And this one better be 93, right? Because these two better add up to 180 and these two better add up to 180. So we got 23 for y. So 3 times 23 plus 24. 3 times 23 is going to be 69. 69 plus 24 is 73, 83, 93, which is our correct answer, right? So it all checks out. Our x and y values are good. Now on to the proofs, number 5. So we have start our proofs with our givens. So we got to write steps and justifications, and then we got to write our givens. So we're given that M is parallel to N, and we need to prove that angle D is congruent to angle E. So we have steps and justification. So step 1, M is parallel to N, and that is given to us. Now we can use all of our angle theorems that have to do with parallel lines. Okay, so we want to prove that D is congruent to E. They're alternate interior angles, so basically what we're trying to do here is prove alternate interior angles are congruent. So we can't assume what we're trying to prove is true. Okay, we got to use other means to prove it's true, so we got to go in an indirect way to get from D to E. So we got to go to something else from D before we can go to E. So we need to pick something that D is congruent to that is also going to be congruent to E. And we have two options. We can either do corresponding angles to H, so D and H are corresponding angles, or we can go to A, which is a vertical angle. Let's just go to H. Okay, either one would be fine. Let's go to H. So angle D, what do we know about angle D and H? Right, we said they're corresponding angles. Okay. We know they're going to be congruent because corresponding angles are congruent by the corresponding angle theorem, which says if the lines are parallel, which they are, then the corresponding angles, which is D and H, are going to be congruent. Right? Angle D is congruent to angle H by the corresponding angle theorem, which says, that's why we have to have the given. If the lines are parallel, then the corresponding angles are congruent. We're given that they're parallel, so then we can conclude that the corresponding angles are congruent. Okay. So we have gone from D to H. Okay. We know D is congruent to H. Can we get to E from H? And the answer is yes. H and E are going to be congruent. Why are H and E congruent? They are vertical angles. Okay, so angle H is congruent to angle E, right? Because they're vertical angles, and the vertical angle theorem tells us that vertical angles are congruent. All vertical angles are congruent. Okay, so now we've gone from D to H to E. So we know D is congruent to H, and H is congruent to E. Okay, so we can use the transitive property of congruence, transitive property of congruence, to prove what? That D is congruent to E. So angle D is congruent to H, and angle H is congruent to E, then angle D is congruent to angle E. If two things are equal to the same thing, then they are equal to each other. If two things are congruent to the same thing, then they are congruent to each other. Both D and E are congruent to angle H, so D and E are congruent to each other. Right? The transitive property says if A plus B, if A equals B and B equals C, right, so this is the transitive property. If A equals B, if, and B equals C, then A is going to equal C. So if, right, we could say angle H is congruent to angle, let's start with D. Angle D is congruent to angle H. and angle H is congruent to angle E, then angle D is congruent to angle E. Right? If two things are equal to the same thing, they're equal to each other. That's transitive. The other way you could have gone is you could have said substitution. So instead of saying transitive, we could have said, look, instead of putting an H here, right, we're going to substitute in a D. Right, we're going to substitute. We're going to replace the H with a D. We're going to substitute the H for. We're going to substitute a D for the H. Okay, but then you would have had to have substitution property, but that would have been perfectly fine. Okay. So we want to try. We can't go directly from DE. We want to try to go indirectly there. The other way we could have done it: vertical angles with A. So angle D and angle A are vertical angles. Then angle E, and so angle D is congruent to angle A by the vertical angle theorem. Then angle A is congruent to angle E by the corresponding angle theorem. And then angle D is congruent to angle E by the transitive property, or by substitution, whichever you prefer to go with. Number 6. Okay. Number 6. Here we have, given that M is parallel to N, so that is going to be our given. So our two lines here are parallel. Angle C and E are supplementary. So we know angle C and E are same side interior angles, so we know they're going to be supplementary. But we're trying to prove that. So we can't assume it to be true. We need to show that it's true using other theorems and postulates. Okay. So our goal is to get from C to E. Okay. So we're going to need to pick another point that's congruent to one of them, but supplementary with the other. That way we can say that those other two are supplementary and then replace that with a C. So we want to find something that's congruent to C, and then we can substitute in whatever that is. We can substitute in the C for whatever that is, if that is going to be supplementary with E. Let's go through it and we'll see what I mean. Okay. So we're at C, we want to get to E. Let's pick something that's congruent with C. Okay. One thing we can have is F. Okay, so these are alternate interior angles. So we know by the alternate interior angle theorem, okay, that angle C is congruent to angle F. So if the alternate interior angle theorem says if the lines are parallel, which they are, then, right, if the lines are parallel, then the alternate interior angles are going to be congruent. So then angle C is congruent to angle F. And we also, 3, okay, want to try to get to E now. Okay. So what's the relationship between angle E and angle F? Right, well, F and E are a linear pair. They're the same vertex, so it's vertical pair or linear pair. They're right next to each other. They form a straight line. They form a straight angle. They're going to be a linear pair. We know linear pairs are supplementary, so we know their angle measures add up to 180. But for our case, we're good with saying they are supplementary. So angle F and angle E are supplementary. And why are they supplementary? That's just the definition of supplementary, or definition of a linear pair, whatever you want to put here. Definition of linear pair. Okay, linear pairs are supplementary. Okay. What's the linear pair theorem? I don't remember what the linear pair theorem is exactly. The linear pair theorem says linear pairs are supplementary, then you would put linear pair theorem here. But either way, same difference. Okay. So now we have C to F, F to E. Okay, what can we substitute in instead of F? What are we trying to prove? All right, we're trying to prove that angle C and angle E are supplementary. So we're trying to prove that they're supplementary. All right, so this is what we're trying to prove. Okay. So instead of putting a F, right, notice these two are the same statements, except instead of putting an F, we put a C. Well, we know we can replace it. We can substitute in the C because we know C is congruent to F. Okay, so we can substitute. This is substitution. Okay, we're substituting, right? These are the same statements. Angle F and angle E are supplementary. It's the same statement as angle C and angle E are supplementary, except instead of putting F, we put C. Okay, it's a little hard to read, but right, instead of putting F, we're going to put a C. So angle C and angle E are supplementary. Okay, and we did that because we substituted in the C for the F because we know they are congruent. That is quiz 3 from unit 2. Any further questions, again, just come see me, ask me. I want to help. I want you guys to pass. But I encourage you to retake it and ask more questions if need be. Okay. Only half an hour for that video, so if you need more detail, let me know.